Welcome to YouTube channel Tech Guru Gautam Prasad. In this video, we are going to discuss about this DC current electricity. So, in order to understand a DC motor, especially if you are a beginner, this is going to help you in understanding the functionality of the DC motor properly. So, let's see what is DC current electricity and associated magnetism in the electrical conductors. So electric field is something that uh, emanates from the charges. So on the right side we have a positive charge. You can call it a point charge, and on the left side we have got a negative charge. So you can see electric field is radiating out from the positive charge, whereas uh, the negative charge electric field is going inward, that means into the charge. So lines of forces are going into the charge and coming out from the positive charge. An electric field radiates outward from the positive charge and radiates towards a negative charge. So that is the end conclusion here. Now going to the next slide, moving forward. Current electricity is the movement of electric charge from a conductor. So the current is measured by the amount of the charge passing through the cross section, particular cross section of the conductor in a given period of time. So that is why current is measured in coulombs per second. And a conventional current flows from the positive battery terminal to a negative battery terminal. That's a conventional direction of flow of the current. So here electric fields drive current electricity. So as you can see, uh, positive charges are trying to drift towards the negative charges, and thus the current flow starts. Conventional current can be assumed to flow from the positive side to the negative terminal, positive terminal to the negative terminal, or cations to anions. Here a battery has been shown that has got two terminals, one positive terminal and the negative terminal. Positive side of the battery is having positive charged ions, whereas the negative side has got negative charged ions. And battery is use electrochemical reaction to produce dissimilar charges used to create current in the DC motor and circulates it. Ions contain charges and that can create electric field. And because of this field, there exists a potential difference between these two terminals, and that causes, you know, the current to flow. That is sometimes also termed as electromotive force, EMF in short. And this EMF is, as it is named, electromotive force that mm, uh, moves the electrons through the conductor, and the direction being from positive to negative. That's the direction of conventional current, as we talked earlier. Here also, the current flowing has been shown from positive towards the negative terminal through a resistor. Resistor could be considered as the load, and once the load is connected between these two terminals, the circuit completes, and as because the circuit completes, current starts flowing. And as we talked, this current is nothing but the flow of the charges. So basically, from positive side, ions are flowing towards the negative side. Okay, and a current created by the unidirectional movement of the charges through the conductor is called direct current. If there is no variation in the current, that means if the current is uniform and constant in a magnitude and flowing constantly in one direction. This is called a DC current. And batteries produce DC currents. And here also, these two terminals have been shown in a different way. This is a positive terminal, this is your negative terminal. Current is flowing from negative to positive to negative terminal. And when it flows through the conductor, you can see here the conductor has been shown. The conductor creates some magnetic lines of force, and this magnetic lines of force can be assumed to be for a current, in the clockwise direction. Here it has been shown, and this can be predicted with the right hand cork screw rule. So if you tighten a screw like this, it goes downward. So if you assume the direction of this screw is as the current, direction of the flow of current, then the rotation, direction of rotation gives you the direction of the field, magnetic fields around the conductor. So that is how you predict the conductor. At the same time, if you unscrew this screw, then the rotation will reverse, and the screw will come upward. So for upward direction of the current, this field is going to be anti-clockwise. For downward, it is clockwise. For upward, it is uh, anti-clockwise. So that is how we talk about the magnetic lines of force created because of the current flowing in a conductor. And now we have a right hand rule that also helps you to predict the direction of flow of the current and associated magnetic lines of force. If you keep your thumb upward and wrap your four other fingers around the conductor, then the direction of your four fingers around the conductor gives the direction of the magnetic field, and your thumb gives the direction of the current at the same time. So you can understand the relation between the direction of the current, at the same time direction of the magnetic lines of force or magnetic field uh, caused because of this current in the conductor. So this is pretty simple to understand. At the same time, it is quite a lot helpful in understanding the behavior of conductors in terms of coils in the DC motor. So the direction and the motion of the induced magnetic field in the conductor can also be understood in this manner. The current, if it is coming outwards towards you, of coming outward from the screen towards you, then this will cause uh, uh, direction which is anti-clockwise, and if it is going into the screen from your eyes side, from your eyes to into the screen, then this will create a magnetic field of clockwise as shown on the right side picture. So you can predict it like that for the mm, for the two different directions of the current, into the piece of the paper or out from the piece of the paper, or into the screen or out from the screen. Here, current and magnetism in a coil has been discussed. So you have a coil here that is wrapped on a piece of iron piece, that is wrapped on an iron piece, and you are feeding this coil with positive and negative terminals connected on it. So when you connect it, current starts flowing into the coil, and at the same time, when it flows, it creates magnetic field because of the current flowing into the conductor, and because of this current, it develops south and north pole. On the positive side, it creates a north pole, whereas on the south side, it creates a negative pole. Negative side creates the south pole, and positive side creates the north pole. So that is how we can predict the direction of the current and associated magnetic field in a solenoid coil. Motor armature rotation is caused by the simultaneous interaction and uh, attraction and repulsion between the electromagnetic field in the armature and the fixed magnetic field. So here two magnets in gray color has been shown, and the flux because of this is straight. So when a conductor is placed and the conductor is connected to the positive and negative uh, terminals of a DC power supply, then the current starts flowing through the conductor, and this current, causes a magnetic field of its own in the conductor, as we have discussed earlier. And because of the two magnetic fields interacting with each other, some something is going to happen. We will discuss later what is going to happen. So this interaction is taking. This is very important to understand that these two magnetic fields start interacting with each other. And what is the result of this interaction? What it is going to do with this conductor, that we will understand in the subsequent slide. So here, a conductor in a fixed magnetic field is, you know, when the current is coming uh, towards you or the observer, and your magnetic field is straight, it will cause this current through the conductor is going to cause a magnetic field that is anti-clockwise. That is anti-clockwise. You can just stretch your hands thumb towards yourself, and then you can see your fingers, four fingers, wrap around the conductor, and that gives you direction of current, direction of magnetic field around the conductor. So these two conductors, these two magnetic fields, one because of the north and south pole of the magnets, and one which is being caused because of the current through the conductor. These two magnetic fields start interacting, and see the result. The straight lines of force caused because of the permanent magnets in the earlier example that we had seen, it started distorting because of the current flowing conductor kept in this magnetic field. So the distortion happens in the straight magnetic field, and this distortion, is not permanent. This distortion, because of this distortion, it tries to straighten. The straight lines of force will try to straighten itself, and in order to straighten itself, it will know, it will force the conductor to move in a particular direction, and this force is nothing but, force outward towards the right direction. Uh, Pushing it towards the right direction will straighten the magnetic lines of force, blue lines of force, and that is how this force is exerted, because of the interaction of these two magnetic fields. So this tells you why the conductors in the DC motor start moving to in one direction. Uh, we will see it later that this happens on two sides of the coil, and a couple of forces start working on the coil. Because of that, it develops a rotating tendency, and ultimately the rotor starts rotating. So here the motor armature in the fixed magnetic field has been shown, that I was telling you in the earlier slide. Here, the direction of the force on the right side is upward, whereas the direction of force on the left side of the coil is downward. Now these two forces are opposite in direction and they form a couple of forces. And because of this couple of forces, this conductor, gets the tendency of rotating itself. If the rotor is fixed on the bearings, and these forces acting on the uh, two coils will turn it. It will start turning it in a particular direction, and the rotor starts rotating. We have Fleming's left-hand rule that better explains the relationship of the current, magnetic field, and the direction of the force. So the Fleming's left-hand rule says if you stretch your thumb, forefinger, and the middle fingers in such a manner that they are perpendicular to each other, then if your forefinger is towards the direction of the magnetic field and middle finger is in the direction of the current through the conductor, then your thumb will represent the direction of the force on the conductor. So basically, if you place a conductor in the magnetic field, in a different magnetic field, then uh, a force will be exerted on the conductor, and this force will be perpendicular to both the direction of the magnetic field and the direction of the current. So that is what this Fleming's real left hand rule says, and this left hand rule applies on the functioning of the motor, working of a motor. So this rule explains better the working of the DC motor. So here also the Fleming's left-hand rule has been once again discussed. The conventional direction of the current and the direction of the force has been, explained. So here you can see the direction of force is in the upward direction on the left side of the coil, and similarly on the right side it will be in the downward direction. You can observe here that you are feeding the left side of the terminal with positive uh, terminal of the battery, and right side of the terminal with negative terminal of the battery. So the direction of the current has been reduced as compared to the earlier slide. So you are seeing the direction of reversal of the current. So if you interchange the terminals, this concludes like this. If you interchange the positive and the negative terminals of the coil, then probably it will not probably, it will exactly change the direction of rotation of the motor. So that happens, you can see it practically, we show it in the labs by connecting the motor and interchanging their terminals. So here use of the left hand rule to determine the rotation direction of the armature in AB, and uh, hint, you will have to turn your left hand upside down for the example A, and notice that when the current through the armature is reversed, it moves in the opposite direction. So that we have already discussed, my friend. So I don't think you have any doubt in explaining these two photographs. So try yourself these two photographs. Mm, uh, try to guess the direction of a force acting on one side of the coil and the other side of the coil at the same time, and this will help you in understanding the working of the DC motor. So magnetic forces acting around the parallel conductors, current carrying conductors. Now here, these two conductors in red, the current is flowing towards you, towards the observer in these two conductors. Now these two conductors are running parallelly. When these two conductors are running parallelly and the current is flowing in the same direction, then you can see the magnetic lines of force being caused because of these two in the anti-clockwise direction, and these magnetic lines of force are supporting each other, and there is a common magnetic lines of force that has been drawn like with the help of the outer lines. So this combined magnetic field is telling you that these two parallel conductors will start attracting each other if the direction of the current is same in these two conductors. Okay, so for the same direction of the current, two parallelly running conductors will attract each other. Here, if they are the direction of the current is opposite in these two conductors, they will repel each other. With the same fundamental, as we talked now, the inward, uh, the current coming towards you is having a anti-clockwise direction of the clockwise direction of the magnetic field, and the current going into the surface of this screen, that is causing anti-clockwise direction of the magnetic field, and these two magnetic fields are again interacting with each other to repel each other. So the first field is causing the other uh, conductor to go away from that conductor, and the similar thing is being done for the another conductor to the first conductor. So in turn, they start repelling each other. They start drifting away from each other. So for the opposite direction of the currents, two parallel conductors repel each other. That is the conclusion. Magnetic forces acting on parallel conductors, current carrying conductors. So here in the coil also the conductors are parallel. So here that analogy has been discussed. So you have uh, on the left side, the current is coming towards you, and on the right side of the red circle, the current is going into the surface. So the whole thing can be imagined to be, in the case of, this is happening in the case of a coil, a solenoid coil that we had seen. Here also the same thing has been shown, and there also the positive terminal was developing north pole and the negative terminal was developing south pole. So here it happens like this. They repel each other at the same time because they are running parallelly, but at the same time they develop uh, poles on two ends of the conductors, two ends of the parallelly running conductors. So in the coil, there are a number of turns which are parallelly, running running along, and they cause the magnetic lines of force to behave in this manner. The armature of the brush commutated DC motor is made of the current carrying conductors wrapped around the iron core. So here is the iron core, and this winding is wrapped around, in the slots of this armature. Now, because of the similar kind of parallelly running conductors, so some, you know, uh, poles will be created in this conductor, and because of these poles interacting with the main pole of the DC motor, there will be some movement, in these conductors. The motor armature is an electromagnet and operates according to the principle described in this slide. So earlier we have already discussed, it is referring to that concept that we have already discussed. So that's the end of this discussion, my friend. Hopefully, you have understood the uh, behavior of the DC current and its associated magnetic behavior when it flows through the conductor, and that will definitely help you in understanding the concept of working of the DC motor. So, thank you very much for staying with me till the end of this video, and uh, stay tuned with my YouTube channel. Keep commenting so that I understand um, how better you understand uh, through my videos and how you appreciate this. So your words will definitely be guiding to me. Thank you so much once again.